Hello guys, and yeah, this is the stream again. I'm live because is anyone in here? A 100 views, oh my god. My live get 110 views.
A break card. Haven't seen a break card for a long time. 90 buzz.
Oh my god. Yeah, a minute ago.
The top 10 ways in which the universe can destroy the Earth. At number 10, the universal Big Rip. Far into the future, dark energy will push the universe to become so large, it will be infinite in a finite time. Every atom and subatomic particle will be ripped apart, and our bodies would be torn from the inside out. But this will take billions of years, and it's only a theory for now. At number 9, an intergalactic collision. The Andromeda Galaxy is on a collision course with our own galaxy, the Milky Way. Coming at us with a speed of over Mach 300, this event will take a few billion years, so we have plenty of time to make an escape plan. The Earth may still exist after this collision, since the probability of colliding with a foreign galaxy star is actually quite low. At number 8, cosmic space dust. These clouds of dust form planets and even developed Earth at one time in history, but they can also be our end. As our solar system travels along in our galaxy, there's a chance we might even hit one concentrated nebula. Dust would slowly eat away at our oxygen, and cosmic rays would become more of a threat. It would be a slow, but guaranteed painful death. At number 7, a solar superstorm. As we become more dependent on technology, a solar flare can knock out satellites, power cell phones, and even water supply. Civilization would be thrown into the Stone Age again, and losses could result in trillions of dollars, and a full recovery would take years. We could prevent a lot of this damage caused by these storms, and transformers could be built with capacitors and resistors, but it has been avoided due to high costs and lack of government support. At number 6, an asteroid. The most probable deadly threat out there, and depending on its trajectory, an asteroid several miles wide can do widespread damage to our planet. In 2009, Jupiter even got hit by a fragmented asteroid, a powerful event which was 1,000,000 times greater than the bomb dropped on Hiroshima. Most asteroids travel about Mach 65 or 50,000 miles per hour. But the most alarming thing is that new asteroids are being discovered every day. That's number 5, a rogue planet. Far more devastating than getting hit by an asteroid, there could be a planet unbound, free to any star traveling towards Earth. Believed to be ejected from a gravitational event, rogue planets can theoretically travel millions of miles per hour. That's number 4, a hypervelocity star. These gigantic stars travel millions of miles per hour through space, likely to be thrown out by some type of black hole. These stars are unbound to the galaxy and could be as big as our sun. Luckily, only a handful of these rogue stars have been discovered in our galaxy. That's number 3, a rogue black hole. Hundreds of these black holes could be traveling our own Milky Way, waiting to collide with our own solar system. Any planet caught in its path would be devoured and tossed around in space. Earth's atmosphere would be torn out, and its crust would be fragmented and pulled towards the black hole of death. That's number 2, a magnetar flare. These ultra-powerful magnetic neutron stars can have a mass of up to 2 times of the sun, but only be 12 miles across. It can contain 1 quadrillion times more powerful magnetic field when compared to Earth's. When these great stars erupt energy, it expels radiation in the form of X-rays and gamma rays. There could be hundreds of these stars in our galaxy when flare even hit Earth in 2004, knocking out several satellites and partially ionizing Earth's atmosphere. The scary thing is that it was over 50,000 light years away, so we got off lucky. That's number one, a long gamma ray burst, more powerful and longer than short ray bursts. These bursts come in narrow beams resulting from huge stars collapsing, collision of stars, or even a black hole. It has been claimed that just one gamma ray burst in our galaxy would just poison Earth, would destroy every living thing. These high energetic beams will release more energy in a few minutes than the sun will in its entire 10 billion year life. Our ozone layer would be torn apart and the planet would be covered in a photochemical smog. Earth's destruction is pretty much guaranteed by humanity or by one of the events in this top 10 list. So once again, support the colonization of space, like this video, and please subscribe to my channel.
Okay. That was awesome.
More than 4 billion space bodies, aka meteoroids, fall into the Earth's gravity well every day. This moniker covers everything in size greater than interplanetary dust, but less than that of an asteroid. These are small stones in the majority, which quickly burn up in the terrestrial atmosphere. Only a few can pass this barrier. Meteoroids that reach the Earth's surface are then called meteorites. At the same time, they do not pose a particular danger, although occasionally they can make local residents nervous, as happened recently in Chelyabinsk. But what if we increase the velocity of the meteorite to the speed of light? No particle with mass is actually capable of the speed of light, but in fact, for our purposes, we don't need it. It will be enough simply to approach this speed, just a little, such that the entire solar system will be in shock. But let's do this in the proper order. Imagine that we have a round diamond ball 30 meters in diameter, and we have just launched it in the direction of the Earth at a speed of 3,000 kilometers a second. First of all, it should be noted that the air in our atmosphere begins to participate in nuclear fusion at such velocities, and with this plasma heating, the process might be able to destroy our diamond sphere entirely before it reached the Earth's surface. But the Earth will not get the better of us. This sphere will not fly wide enough and at some point will crash into the Earth. 1,000 times more energy will be released during the impact than from the most powerful nuclear weapons of all time. And at the same time, the entire region near the point of impact will be wiped clean.
94.
This is boring.
I mean,
it's only 0.01 of the speed of light.
12.
The crater will be huge. This heat will cause stone to be dispersed at 0.99 the speed of light. Here, relativistic effects are beginning to act. Links that hold the sphere as a single entity completely fail. A diamond meteorite becomes just a bunch of carbon atoms, moving so fast that a Lorentz contraction flattens the sphere into a pancake. We would, of course, not be able to notice this visually. Each carbon atom in the sphere carries about 70 billion electron volts of energy. They're moving too fast to collide with the air directly and simply pass through it. Molecules of air penetrate through 3 meters of the sphere and then get stuck inside. It expands rapidly and reaches the Earth with a greater content of matter than at the beginning of its fall. When it hits the surface, it disintegrates completely, rending the Earth, generating a deep and wide cavity, and creating a cone-shaped channel through the Earth's lithosphere. The energy of the collision will crack a hole in the Earth's crust and knock out so large a crater that through it you should see the molten mantle. The collision will release energy similar to 50 times that of the Chicxulub asteroid that killed the dinosaurs. This is enough to cause a mass extinction on the planet, if not the end of all life in general. Would you like to witness such a grand performance? I'd rather not. It's boring. Let's add another few nines. 99.999 the speed of light. Now, each carbon molecule carries 25 trillion electron volts of energy, which is comparable to particles in the beam of the Large Hadron Collider. Under these conditions, all of this will hit the Earth with roughly the kinetic energy of the Moon moving in orbit. This is enough to punch a tremendous, massive hole in the mantle, and to disturb the Earth's surface so much that it melts completely. This, with even greater probability, will put an end to all life on Earth. But, damn it, it's still not enough. Let's add just a few more nines. 0.9999, 9999, 9999, 999, 999, 9999951% of the speed of light. The speed of the fastest object that has a mass, which has been observed by mankind, will be obtained. The oh my god particle, as it is colloquially known. But let's not blame God for this. The oh my god particle is a proton from space, which plowed into the atmosphere over Utah in 1991, and it was moving at almost the speed of light. 99 point followed by
science, guys.
21.951
Science.
the speed of light. The cascade of particles that were formed from its collision could not even be reproduced in the Large Hadron Collider. A similar phenomenon is detected several times a year.
This is considered as cheating because these are the answers for the planets you topic on.
But what happened there to make them leave in such a hurry? And why didn't they slow down before they got here? In general, let's leave this mystery to the scientists and give our diamond ball the velocity of the oh my god particle. Now, this thing will be flying so fast that no modern computer technology can simulate such a situation. Therefore, we cannot know for sure how everything will turn out, but we can roughly outline the picture in general terms. Our diamond ball sweeps through the atmosphere, not even noticing it, and disappears into the Earth's crust, a cloud of expanding...
Dang it.
Delectable coffee crumble and your delightful double done now in new solo packs. Sarap ng...
Sometimes the cosmos can be a little boring, so let's be naughty. Why does the Earth need the moon? Why not put a fidget spinner in its place? What would happen if a super giant mega fidget spinner took the place of the moon? For convenience, let's assume that the mass of the spinner is equal to that of the moon. If so, then its diameter will be much greater than the diameter of the moon, as the density of a spinner is less than the average lunar density by about 1.5 times, and the spinner isn't spherical and has holes. For example, if all the spinner's matter were collected into a sphere, it would be larger than that of the moon. Anyway, its diameter will be 3,500 kilometers more than the diameter of the moon, due to its, in terms of physics, ineffective form. The spinner will reach a minimum of 10 and perhaps even 15,000 kilometers in diameter. What will happen to the Earth basically depends on the position of the spinner in orbit and the side to which it would spin. But first, let's talk about changes that do not depend on its orientation in space. The spinner is, of course, made of plastic, and plastic reflects light 5 times stronger than the moon. If the spinner is turned on its edge towards the Earth, the brightness of our nights will hardly change, because only a small part of the spinner will be visible. But if it is turned to face the Earth, our nights will be about 20 times brighter, as the spinner shines with reflected sunlight. If the spinner isn't white, but some other color, then our nights will be painted in this same color. But if it's black, our ordinary earthly night will become completely dark. Our main light source will disappear, and only the stars will remain, which is not enough for even minimal illumination of the Earth at night. Perhaps the spinner will create its own magnetic field by spinning. If it does, it will overlap with the Earth's magnetic field, protecting us even further from solar radiation. But this will do some harm to some of our animals, as many of them orient themselves along the lines of the Earth's magnetic field. The new spinner-moon magnetic field would likely confuse them, forcing birds to migrate by more habitual routes, and confusing fish rather will resemble the sudden turning off of a light. Well, now let's talk about truly disastrous consequences. If the spinner is parallel to the Earth's equator, it will strongly influence the rotation of the Earth by its rotation. Rotating in the same direction as the Moon, it will, in a way, untwist the Earth, shortening our day to several hours, and maybe even just to tens of minutes. The thing is, the spinner blades, because of their huge mass, will have a powerful gravitational effect, and due to the fact that they protrude far beyond the center, their influence on the Earth.
Okay, let's go back to GD. It's enough of that. Alright, Daniel. I'm going to do your level. Cause, you know, it's a level quest. And why isn't this thing... Oh, shoot. Let's go to GD. Oh, for some reason, Geometry Dash isn't working. Okay, Daniel, we'll do your level. Four 0088428. Jungle Swings. What time is it for you? Mine is 6:10. Oh. Yo. Yo, this is hard. Oh! Okay. Okay, that's great. I'm gonna give that 8 stars. So yeah, do you have a hardest demon in GD? Well, my hardest demon is Hypersonic. Hypersonic.
Earth will be much stronger than the influence of the Moon. The direction of rotation of the spinner blades and the Earth will coincide, and the blades will pull the Earth with them, speeding up its rotation. If the rotation of the blades is in the opposite direction, the Earth will slow down. The mass and inertia of rotation of the spinner will not suffice to leave the Earth's orbit, nor to reverse its rotation, but our day will greatly increase, perhaps up to 30 or 40 hours. The spinner will stop quite quickly by the standards of outer space in only a couple of hundred or thousands of years, since by transferring gravitational energy to accelerate or slow down the rotation of the Earth, it will lose speed in its own rotation. Now, if the spinner is turned to the planet on its edge, then it will move the Earth's axis. The blades will now pull the Earth up or down. When rotating downwards towards the southern hemisphere, the Earth's axis...
Oh. Who watched it?
Welcome back to YouTube Rewind. We've got 2 special guests with us.
Okay, Layla and Liza, tell me about 2017.
Marshmallow.
Nobody pray for me. Give me that day for me.
Roy. Oh. Cool. Start the scene. Copyright! Oh my god, copyright!
Copy.
Copy.
Commanded.
Okay, you can spam it.
Somebody wants to show me the world is gonna roll me. I ain't the sharpest tool in the shed. What's that?
Houston area still is in a state of disrepair. Reports of an explosion.
Mexico no gata Barcelona atyanta తీవ్రతతో
Very difficult time, but we've been through very difficult times before.
So many brothers and sisters that have come to help.
The community rallying to show its support.
Junto con voluntarios, se organizaron para retirar los escombros.
Long lines that are now wrapping around one of the blood banks.
And that are doing all they can and are helping.
Vivre ensemble, c'est bien, mais construire ensemble, c'est encore mieux.
Oh my god.
All I want to do is say, for a minute, you stay your time, like, you know, cool.
Marshmallow scene and Jake Paul and Logan Paul. Oh. Don't you know that I am the one for you?
No.
Don't you know that I am the one for you? I'm focused. What? Mark. now.
Sorry, guys. Looks like you were interrupted there. You were about to tell me about 2017?
It was good. Okay.
Okay, I'm going to end the stream. I'm going to stream tomorrow, okay? Okay, bye.